Alright, let's go through a few questions in this video that the students sent to me. So this video will include questions that you sent or maybe sent by your classmates. Now, substance Q's freezing point is 35 degrees Celsius and boiling point is 70 degrees Celsius. So, which of the following shows the correct state of substance Q at 30 degrees Celsius and at 80 degrees Celsius? So let's take a look at this. Let me draw the model to show this. So Q's, I'll draw it here, okay? So Q, I have my freezing point, which is the same temperature as the melting point, and as well as the boiling point. Now boiling point is 70 degrees Celsius and freezing point is 35 degrees Celsius. Clearly this substance is not water, which is fine, okay? We can give you questions that are not water as well. So what is the state of Q at 30? 30 is below 35, alright? Therefore, if 30 is here, it means that it is a solid. So it must be solid at 30. How about at 80? At 80 means it is above the boiling point. If it's above the boiling point, therefore it got to be a gas, right? It got to be a gas. Just for a moment. It became very blur for a while. Alright, so it's a gas. So if it's a gas, that means that it has to be, our answer is number 2. Okay, answer is number 2. So the answer for this is number 2. And this is the working that you use to do it. Gas at 80 degrees Celsius and a solid below 35, which is at 30 degrees Celsius. Now, next question. Now, okay, this part I think you got part A, B largely correct, but I need the correct answer for part A. So Muthu conducted an experiment with two different springs, A and B, of the same length during the using the setup shown below. Now, just a quick recap. A spring, before you add any mass to it, it has a length. You call this the original length. Okay. A spring, after you add a mass to it, now there are two new words or sets of words here. This will be the extension and this one will be the extended length. So here we talk about extension. Now clearly the more mass you add or the greater mass you add, the greater it extends. 100 grams, it extends. 200 grams extends some more. 300 grams extends even more. And comparing these two, it's very clear that A is a stiffer spring than B. Alright, stiffer spring means it requires more force to compress it or more force to stretch it. Stiffer spring also means if it is compressed, it stores more elastic potential energy. Notice the difference between forces and energy. Don't confuse these two. Now, so when you talk about weight, is about force, because weight is the gravitational force that's acting on a matter. When you talk about mass, it is not a force, because you can have mass and have zero weight. You can be floating in space, you weigh 0 kilograms, but you have mass. Okay? There's no force, alright, because there's in space. This is why you cannot equate these two. You can have mass, but you can have no weight, depending on where you are. Therefore, when we talk about heavier, we link heavier to the idea of weight. So whenever you say heavier, you're talking about weight, which is a force. And this tells me there's some confusion here because you're talking about mass, and mass is not force. So I would prefer if this you use greater. The greater the mass, the greater the extension. So here actually I'll mark you wrong because this suggests to me a wrong concept. Alright, if you use heavier, I will think you talk about mass thinking that it is a force. Okay, this is correct, right? There are two forces acting on the mass. Gravitational force pulls it down, elastic spring force pulls it up. So yeah, this is correct, 1 mark. And this question, next one. Now, you use the same two springs, right? And try to be a jack in the box. So firstly, they put the jack in the box. They put a spring A inside here. Remember, spring A is the stiffer one. So if you compress a stiffer spring, it will have more elastic spring. It will store more elastic potential energy inside. So here, correct kinetic and correct potential. And this potential is only elastic potential energy, not chemical, not gravitational. It is elastic potential energy. And you rightly noted that this is a plural, main forms. It is not like forms and bracket S. If this is the case, I will just choose one. Between these two, this is really the main form. Now, when it jumps up, it's as it is moving out. So it is not after it has jumped. It is not before it jumps. So this is during. Therefore, during, it means that the spring is moving. There's Ke. And there's still elastic potential energy stored in the compressed spring. That is still partly compressed. So yes, these two choices are correct. So now it replaces the spring to spring B. Remember, spring B is less stiff. If it's less stiff, it means it has less elastic potential energy inside. If it's less elastic potential energy in the compressed spring B, how do you know it's less? Because we had the data earlier on to show us, right? Spring B extends so much more easily because it's less stiff. So the reverse is true. You compress it, right? You compress it very easily, so it doesn't really store a lot of elastic potential energy inside. So if spring B is a very less stiff spring than A, therefore it will have less elastic potential energy that can convert to less kinetic energy. So it will definitely fly up to a lower height, not higher height. Okay, and explanation comes from the stiffness of the spring. So the evidence comes from the table. The reasoning you talk about the stiffness, the difference in the stiffness, as well as the difference in the amount of elastic potential energy stored inside. They can convert to the different amount of Ke. They of course convert to the different amount of GPE in the toy that goes up. Okay, you can try the answer and send it to me again for me to check your answer for you. Okay. Now, next one is sent back to me by another student. So, I think you took the paper from some of those things you purchased outside, right? And you check the answer key. So, your answer, really speaking, I look at your answer is correct. So, this answer key provided for you in that set of paper is wrong. Just to make sure you understand, when you buy those papers outside, very likely, I think the questions are legit. They are from schools, although that's not legal. Those tuition agency or tutors shouldn't be scanning their students' work, remove their working and come up with their own answer key. So the questions are fine, but I think the problem lies with the answers. I think on the whole they are largely okay, but you cannot trust them 100%. Right? So in this case here, your understanding is correct. So I will not go through the explanation for this. Now likewise for this question, your answer is also correct. The answer key is wrong. So I also will not be going through in detail because you explain it. I think your answer, I think you understand this. That's why you got it correct. Okay. Now for those who are trying this and you're not the one who sent this to me, and if you don't get answer for, you can ask me why. Okay. Now, then you ask me this question. Now, for this question, I need to clarify, this one is actually not a practical thing. It actually cannot work. So, but because the question has been provided, so we should try to solve it. But this is not a question that can work, alright? Now, again, I agree that here, the answer, both answers here are wrong. The answer here should be 1. Now, how do I get to the answer 1? So basically it's this. You know that steel is a better conductor of heat than wood. So better conductor means if I put the flame here, the steel here will conduct the heat away from the paper. So the paper doesn't burn so easily. Whereas here, because wood is a poorer conductor of heat, the heat that is applied to the paper, which is just above the wood, will not be conducted away so easily. Alright? So the paper around the wood becomes burnt rather than around the steel. But as I mentioned, this one cannot work because this is a piece of paper. If you've ever seen a paper burn, or you ever burned a piece of paper, you know the whole piece will just burn in seconds, no matter what you put underneath it. So a better way of doing the experiment is actually to have two rods, a steel rod and a wooden rod. Both you wrap with a piece of paper of the same type and thickness, and then you apply flame to both of them. Okay, and then you will compare and see how long it takes for each piece of paper to catch fire. This kind of thing may work, and please don't try this at home. If you ever want to do such experiments with fire, which is very dangerous, you should always do it with an adult present and ask for permission. Never do on your own. When this doesn't work, okay? Now, I'm also wondering the meaning of the word burns. Does burn means charred, or it means catches fire? Because they are very different. I can char a piece of paper and it doesn't catch fire. Basically, it must reach ignition point. Yeah? There's a point in time when you heat it, such a paper reaches a certain temperature and then it will catch fire and ignite. So I'm going to take it that it means catches fire, or whichever one, because I'm not quite sure what does burns mean in this question. So this one here will burn, alright, will catch fire as a steel conductor heats better. Now, you can also know without even looking at the picture which options are wrong. Wood conducts heat better is wrong. Wood conducts heat better is wrong. So 2 and 4 are definitely wrong. So this answer key, provided you answer 4 right, is definitely wrong. Now the question is, what does burn means? Okay, so I will take it as a better way to understand is burn means catches fire. Catches fire means it cannot conduct heat away so easily. So it conduct it away. Here doesn't conduct, so here it has to become charred. And then start to catch fire after that. Right here, no. Right, it doesn't work. Okay, so don't need to try this at home, it doesn't work. The whole piece will just catch fire. Now, this question here, the answer key is actually, I think, correct. Alright, your answer here is wrong. No. Why? Firstly, you should know that we talk about degree of transparency. Tracing, so the most transparent will be clear plastic. It lets the most light pass through. Most light. Tracing paper lets some light pass through. Some light. And cardboard is opaque. Let no light pass through. This is 0. So yeah, that's why this is the answer. It cannot be 3, because 3 are talking about the amount of light it passes through, right? Differs over time. Why would it differ over time? Over time, more and more light somehow can pass through those materials. Doesn't work, right? More light may be able to pass through plastic if you move the light source nearer and nearer to the material. Or more light can pass through tracing paper when you move it nearer and nearer to the material. But if it's an opaque material like cardboard, if you move the light source nearer to the cardboard, it also will not increase. And that will be distance, not time. Okay, so here is time. So no matter how long you put it in front of the candle, flame, or the torchlight, the amount of light that passes through will be the same, so long as you keep the distance between the light source and the material the same. I'm referring to, let's say this is the light source, this is the material, and this is your sensor. If this distance is kept the same, this is kept the same, alright, the thickness is kept the same, then of course you register the same number throughout, no matter how long you test it. Right? So those are all the questions that you guys asked me. So keep it coming. Alright? Remember to rest, relax, and of course do your revision. Bye bye.